Ask someone to recall a list of 20 words in any order, and a striking pattern emerges every time. They remember the first few words and the last few words far better than everything in the middle. This serial position effect reveals something fundamental about how memory encoding and retrieval actually work, and understanding it, along with how deeply information is processed, can meaningfully improve how effectively anyone studies. The primacy effect refers to superior recall of items presented early in a list, explained by the fact that early items receive disproportionately more opportunities for rehearsal, since they enter working memory before competing items arrive, allowing sufficient time for these early items to be successfully transferred into more durable long-term memory storage. Because the primacy effect depends on this extended rehearsal opportunity, it is reduced or eliminated when material is presented very rapidly, since rapid presentation prevents adequate rehearsal even for early list items. The recency effect refers to superior recall of items presented most recently at the end of a list, explained by the fact that these final items remain readily available in working memory at the exact moment recall is tested, requiring no retrieval from long-term storage at all. Because the recency effect depends specifically on working memory availability, it is selectively eliminated by inserting even a brief distracting task, such as counting backward, between the final list item and the recall test, since this distraction displaces the recent items from working memory. Fergus Craik and Robert Lockhart's levels of processing theory proposes that memory durability depends primarily on the depth of cognitive processing applied to information at encoding, rather than on the amount of rehearsal or time spent alone. Shallow processing, focusing on superficial physical or structural features of information, such as whether a word is printed in capital letters, produces relatively weak, easily forgotten memory traces, while deep, semantic processing, focusing on the meaning of information and its connections to existing knowledge, produces substantially stronger, more durable, and more easily retrievable memory traces. Elaborative processing represents the deepest level of processing within the levels of processing framework, involving actively connecting new information to existing knowledge, generating personally relevant examples, and constructing meaningful relationships between new material and previously learned concepts, rather than simply repeating information verbatim through shallow maintenance rehearsal. Research consistently demonstrates that study techniques emphasizing elaborative processing, including self-explanation and generating one's own examples, produce substantially better long-term retention than passive rereading or rote repetition of the same material. Understanding the serial position effect has direct practical implications for effective studying, since middle portions of any studied material, whether a lecture, textbook chapter, or list of vocabulary terms, are naturally under-recalled relative to beginning and ending sections. Students benefit from deliberately allocating additional review time and attention specifically to middle content, and from breaking long study sessions into multiple shorter sessions, effectively creating more beginnings and endings, each of which benefits from the primacy and recency advantages that a single long, undifferentiated study session would not provide. The most evidence-based overall study strategy combines several complementary principles, applying deep, elaborative processing by actively connecting new material to existing knowledge and generating one's own explanations and examples rather than passively rereading, using retrieval practice and self-testing rather than passive review. Since actively retrieving information produces stronger memory traces than simply re-exposing oneself to it, and spacing study sessions out over time rather than concentrating them, since distributed practice reliably outperforms mass practice for long-term retention across virtually every study domain. The serial position effect and levels of processing framework together reveal that memory is not simply a matter of how much time is spent studying, but of exactly how that time is structured and how deeply information is meaningfully processed. Applying these principles, reviewing under-recalled middle content, processing material deeply and elaboratively, and spacing study sessions over time, translates directly into measurably more effective learning.